only crossing the x-axis once. What do we know about when it crosses the x-axis once? Hopefully you thought it or said it. That means that this obviously was a perfect square. Let's go back and look at our original equation to see. If we were to go back and check this by factoring, if we take the square root of x squared, what do we get? X and x. Take the square root of 16, what do we get? 4 and 4. Both of our signs are positive. If we add our middle term, 4x, and the outer term, 4x, does 4x and 4x give us 8x? Yep. So it does work. We have perfect square, so that's why it only crosses the x-axis once. Because if we set it equal to 0 and checked it and subtracted 4 on both sides, we do get a correct answer where our x equals -4. All right, so if I look, this point is 1, 2, 3, 4 away from my middle of the parabola, the axis of symmetry. So I'm gonna go 1, 2, 3, 4 to the left. And there is my parabola. Have I got it? I'm gonna bring it down a little bit more to touch. There we go. And that's how you solve by graphing. Oh, I messed up, guys. No, I didn't. Okay, I didn't mess up. I'm gonna count by 2s on my y-axis, and I'm gonna count by 1s. Just gonna change it on my x-axis. So now I didn't mess up. I counted by 1, so that's -1, -2, -3, -4. And I just counted by 2s at the top. That way I don't have to mess up my graph. But if you counted by 2s and did -2, no, I should have stuck with it. That would have been -2, -4. Yeah, I don't want to mess up my graph. Go back and change yours. So let's count by 2s. So if our vertex was a -4, 0, we would have did -2, -4. So it'd have been right there, just to keep with what we did. So then we would have been 1, 2 away from the middle. So then 1, 2. So your graph would look something like that. But I mean, y'all get the gist. It's just because that y-intercept was 16, so that's what threw it off with counting by 2s. All right. All right, so b is 5x squared minus 10x plus 3. This right here tells us that our y-intercept is 3. So you can go ahead and graph that. It would be 1, 2, 3. There's our y-intercept. And now we're going to find our vertex. X equals -10 all over 2 times a. 2 negatives get married, become a positive, so that becomes 10 over 10, which equals 1. Step 2, we're going to plug it all back in. 5 times 1 squared minus 10 times 1 plus 3. So that gives us 5 minus 10 plus 3. -5 plus 3 means our y is going to equal -2. So our vertex is going to be 1, -2. Come over here. We're at 1, -2 is our vertex. So that means the axis of symmetry goes down the middle there. So if our y-intercept is 3, I'm there. And then one more point right there on the side. If you want to take it a step further, you can go ahead and factor that problem so that you can figure it out. So if we check it, I'm going to just do slide and divide, where I'm going to slide the 5 to the back. So that gives us x squared minus 10x plus 15. My factors are going to be x and x. First sign's a negative, 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 positive. Which factors of 15 can get us to 10? 1 times 15, 3 times 5. Oh, none of them. You're not going to be able to factor it that way. You have to use quadratic formula, which we learn later on this week. So we're going to stop right there. We're not going to check by factoring. And there is our graph. So don't be quick to mark that prime. We're going to learn about what do you do when you can't factor using your factors, using the quadratic formula. because if you kind of look here, you'll kind of be able to tell that it's going to cross the x-axis in between there. So our answers are going to come out to be decimals. And so quadratic formula can give us those actual points where it crosses the x-axis and become a decimal. Example 5, the height above water level of a curved arch support for a bridge can be modeled by this equation, where x is the distance in feet from the arch support, from where the arch support enters the water. Can a sailboat that is 24 feet tall pass under the bridge? So here we have a real life application, yay, where we see a sailboat is going to cross under the bridge, and we're trying to see, is it going to be a tall enough bridge to cross under? You'll probably see several times when you're driving on freeways, you'll see signs that say 13 feet only can pass under this bridge. So they have to use a quadratic equation in order to figure out if it's tall enough. And hopefully some of you have figured out that we only have to find the what? The vertex, because we need to find that axis of symmetry. That vertex, that's the highest point because it is a maximum. So we only need to find the highest point, the vertex that it can cross under the bridge, because that is where the boat is going to cross under at the highest point. So we're going to do x equals negative b divided by 2a. Right here, this is our a, b, and our c. So we get x equals negative 0.84 divided by 2 times negative 0.007. And when we solve that, we end up with negative 0.84 divided by negative 0.014. And when you divide all of that, x is going to equal 60. So we have the x value of our vertex. Now we're going to plug it back in, step 2. And it's going to be negative 0.007 times 60 squared plus 0.84 times 60 plus 0.8. Everybody got that? 60 squared is 3,600, sorry. Times negative 0.007, so that gives us negative 25.2. 0.84 times 60 is going to give us 50.4 plus 0.8. And my paper is running away from me. And then we add all that up or subtract, and you end up coming up with y equals 26. So the vertex for this quadratic function crosses at 60, 26 feet. So since our y is 26, that means that this bridge is 26 feet tall because of the y. So will the 24-foot tall sailboat be able to pass under the bridge? You should get yes. Why? Because y equals 26 feet. So it is 26 feet tall. Got it?